So in the second part of the video, we're going to look at the last type of example with domain and ranges. So the domain and ranges that we started with were either something that we were able to list, in other words, a discrete domain, or some things that we weren't able to list, like a continuous domain. Now we can see on the graphs with a continuous domain is that we were able to always put a smallest and a biggest, whether it be x value or y value. There was always a stopping point and an ending point to both the x and the y axes. So like on this, again, we could see it started here on the x-axis, it ended here, the y-axis, the lowest point and the highest point. So we're always able to find the smallest and the biggest, or the lowest and the highest. With this example now, we can see that we now have the existence of an arrow, so it's just really important for us to take note that when we see arrows, it means that that graph goes on forever in that direction. So they've just taken a screenshot for us, but they said this graph would continue forever and ever and ever going down. So I have a picture of that over here just so we can see that. So this is that same graph, and there's no arrow here because this graph will be able to continue to move for me. So if I keep tracing it, it's just going to continue to go down and to the right forever and ever and ever. You can see my y values are really negative 207. I'm already at the x value of 70. So I just keep going forever and ever and ever. Now with something like this, let's just reset our graph here. When it comes to the x and the y value on these, we can see that there's easily a starting point. So I'm just going back to the original graph. So here I could say, like, where's my first x value? So what I can see is if I go all the way left on this graph, the first x value is negative 2. I can't go past negative 2. So in my notes here, I can easily say that the smallest x value that's on my graph is negative 2. And I'm able to put in that line saying, hey, this is where it starts. It starts here at negative 2. But because of this arrow, I'd ask myself, what's the last x value on that graph? And again, if I just kept going and going and going, I'm never going to get to a last x value. You can see here I'm at positive 57. I can just keep going, and if I keep going forever and ever, this is never going to change. So there is no ending point for that x value. I can't state what the biggest number is. So therefore, all I could say is that the x values on this graph are all bigger than or equal to negative 2. So if we only have one starting point, we only have one number in our domain. Same thing with the range. I can clearly tell that there's the tallest number. I can see that I can't go below this. And again, if I go back to the original graph and try to reset it to where we started, I can see that the tallest point on that graph is right here. I can't go above positive 8. So the same thing I see here, the biggest number is positive 8. So that's the biggest number on my graph. So I could say all the y values are less than 8, right? If I see that here, I can't go above 8, but I can make y values smaller. So here's like 0, negative 5, negative 7, negative 10, negative 20. We're just going to keep going, right? So if I kind of just change my lowest y value, let's go look at negative 100. So here's negative 100, and I can just keep going down forever and ever and ever. Now we're at negative 340. Now this y value is at negative 390. So there is no ending point, so I don't have a lowest value. So my range, all the y values on my graph are just less than 8. So this doesn't pertain anymore. But all the x values on our graph are either negative 2 or bigger, and all the y values on our graph are 8 or smaller. Now moving on to this last example. This last example, we can see arrows on both sides. So let's go look at the graph here a little more specifically. I'm going to reset the standard viewing window from negative 10 to 10. Didn't take there. So negative 10 to 10. So with this graph, what we can see is the first one that we are given is it has arrows moving left and arrows moving right. So if I was asking myself, what's the first x value? Well, since there's arrows, that means this would keep going down forever and ever. So if I try to trace this over here, it's just going to keep going forever and ever and ever. So I'm seeing that my x values are just going to get smaller and smaller and smaller. So I can't find the starting x value because that arrow is going to mean it's going to go left forever. So it's going to go that way forever. Now this arrow, I would just keep following it, so the x values are going to go that way forever. So in other words, if I just kept, where does this last x value on the graph, I'm never going to be able to find it because it keeps going forever and ever. So there is no smallest x value, and there is no biggest x value that I can find. So I can't find the smallest, and I can't find the biggest, so I can't use an inequality. What we're saying is there's any single number I could ever think of, so I'd have to use words. All real numbers. So the domain for this graph is all the real numbers. What we're saying there is if you pick a number, any number you pick, I can find a point with that x value. So if you pick 104, I can go to this graph and find where x is equal to 104, and there will be a point there. If you give me 1.6, I can find where that point is. So again, anything can be for the x value. Now when it comes to the y values, I can easily see there's a tallest point, right? My graph doesn't go above there. If I look on my graph here, if I'm looking at the y values of any point, these are all negative. The tallest y value I could ever get to is right there. If I go this way, my y values are just going to get smaller. So I can easily see there's a biggest y value. That biggest y value is 1. So all the y values on my graph are going to be less than or equal to 1. But if I ask what's the lowest point, well, this line would just keep going down forever because of the arrow. So if I just ask what's the smallest y value, I'm just going to keep going forever and ever and ever. So there is no smallest y value. So my range are all the y values that are less than 1. So as a sentence, what we're saying here is any point on the graph will have a y value of 1 or less. Our last example, what we're going to see here is that we can't use inequalities at all. We'll have to just use words. So if we look at this graph here, it's just a line. I'm going to reset the scale from -10 to 10 on both of the axes. So just a nice easy starting viewing window. Now, on the picture I provided here, we can see that there was arrows, meaning whoever drew this graph, they ran out of space, but they're saying this line goes on forever. So if I was thinking about the domain, what's the smallest x value on my graph? Well, it's just going to keep going forever. So there is no smallest number. If I follow it the other way, if I try to trace these x values, those x values are just getting bigger. So 9, 10, 11, 12, 13, 14. They're just getting bigger and bigger and bigger. And since that arrow is going to keep going, these x values are never going to end. So I'm not able to find a smallest or a biggest. So if I can't use any numbers, I have to use words. So we'll see again here that the numbers that could be on the graph are all the real numbers. So in other words, what we're saying, you can find a point on the graph with any x value as its coordinate. Now when we do the range, the same thing's going to happen. What's the lowest and the biggest y value? We're actually not going to be able to find either of them because of the arrows again. So if I go and try to find, okay, here's where it starts over here at 0, 0. What's the smallest y value? Well, these y values are just getting smaller and smaller, right? So like right here, the y value is -2.95. They're just going to negative, negative. They're going to keep getting smaller and smaller. So I can't find the smallest y value. And if I keep going this way, I can't find the biggest y value because they just keep getting bigger and bigger and bigger. So in other words, the y values that I have on my graph are just anything. There is no smallest, there is no biggest, it's all the numbers. So the range here would be all real numbers. In other words, what I'm saying, you can find a point on the graph with any y value as its coordinate. So whatever you can think of, I can find a point that has that graph, or excuse me, that has that y value. So those are the three major, or some big major ideas when it comes to domain and range. First of all, just knowing the difference between discrete and continuous, but then also looking at the differences between the continuous graphs where I can find the smallest and the biggest endpoints, graphs where maybe I can only find the smallest or the biggest, and then graphs where I can't find either of them.